So, good evening to all of you. Welcome again to a fresh session of this data science and machine learning with Decode Life. We have with us again Honorable Dr. Satyanarayana Rao from Colorado University. So, I am handing over session to sir. Over to you, sir.
Sure. Thanks, Praveen. Can everybody hear me?
Yes, sir. You are audible.
Okay, perfect. Let me share the screen. The screen is fine, looking okay?
Sir, yes, it's perfect.
Cool. All right, okay. So today we will be covering pandas. So basically, now is the part where we are getting into doing like more kind of a science kind of a stuff. Like we are, let's say you are analyst, or let's say you're a scientist, and you don't want to spend so much time in scavenging through data like in files. You want to do something called exploratory data analysis or something like that, right? So you don't want to go here and there and do those analysis. You want just one single window where you can all do all this. So the concept of pandas has been basically inherited, you can say, from our data frames, if you guys are aware of that. um, the idea is that you could basically do what you do in R simply in Python, right? So one thing I want to say here is that it's very kind of evolving. So maybe let's say 3 months down the line, you have some more syntax coming in, and like just to make the analysis more easy in terms of like uh, let's say you had to code 5 lines, but now you just do it in 1 line. So there is no shame in actually looking at examples online, or like how the things are actually changing. So it's pretty evolving, and you just need to hit that keywords that you actually want to get the analysis done or something like that. Like how can I do a line plot? How can I do a box plot using pandas, right? So today our goal is basically to learn the skeleton of pandas, so that we can later on do whatever we want to do on those, right? So it's a big module, and then you have sub modules inside. So for example, panda have series, panda have data frames that we will go through. Primarily we'll focus on data frame today, because that's the first readout you get when you let me turn my that's the first readout that you do generally in pandas. So let's get right into one of the examples that we have been exercising. For example, here, so I kind of went through why pandas, because let's
Sorry
say,
to interrupt, sir. Dr. Rao, can you zoom out your screen?
oh yeah, zoom out.
I
Or zoom.
mean, your font size is a little bit
Oh yeah. I
difficult.
know. Okay. Give me just a second. I basically switch back, and then I forget to bring it on again. Better?
Yeah.
Okay. Here, looking good.
It's now fine.
Okay, perfect. Yeah. So basically, I gave you this motivation of why pandas. Basically, let's say you want to switch to Python, or you want to do some analysis, and you are kind of a pro in R. You can still do those things in pandas. Okay. So now let's basically get into how to actually create a table basically or a data frame from scratch. And the idea is that first of all, you do this import pandas as PD, right? You can give any name that you wish to. The general kind of acceptance in the field now is like, oh, you just do PD. For example, if you do NumPy, which we will cover either today, like both today and tomorrow, if time permits, but definitely tomorrow. So if you say import NumPy as NP, but you can give any other name, whatever you want to give, my panda, my PD, or something like that. That's totally upon you. So how do we actually create a table from scratch, right? So if we look at the structure of a table, let's say I'm just running it here. So how basically a table looks like is you have columns and you have rows, basically a matrix, right? And when you are coding it, you want easier way to actually play with this, right? So Panda gives you that freedom. And along with that, it gives you so many functions to actually do a preliminary analysis, right? So how can we actually create from scratch? For example, you don't have anything stored a priori, and you are actually reading some live thing, right? Then you can create a data frame using this kind of a dictionary. So for example, what you are actually seeing is this is a dictionary, right? Now you have keys which are fruits, city, and price, right? And then you have values, Apple, Delhi, and then you have like price, like let's say for 4 months, January, February, March, April, right? So what it is actually saying that the keys are actually defining your columns. So as you can see that this has been spanned into these columns, and whatever values you're putting in, I'll explain this right away now, that those values are actually going as rows, right? So let me just paste this one here so that you can do it. Maybe I should say dict here, and then I say fruit price df is equal to pt dot just to be on the same page. I would kind of motivate you guys to type it by yourself, but I'm just putting in the chat if time is a kind of a constraint. So what is happening here? Let's give a minute here. You can argue that, oh, you only have one value here, one value here, and then you have 4 values here. How this is happening? You don't have this dimension match like 4 4 4 4 4. What actually is doing this is kind of a special structure, because when you say just one and only one of the keys have multiple values, it just expand on it. As you can see that the city is same, fruit is the same, only the price is basically ordered by month. Let's say if I were to give a month as another column, then I say Jan, Feb, March, April, right? So now it is coming out like this, right? So this is how you can actually create a data frame from a dictionary, because dictionary are like key value pairs, right? But if I interrupt this structure, as I was saying, that these basically kind of key values are telling you that we can, sorry, yeah, we can define this, But let's say if I do some kind of a dimension mismatch, let's say I'm saying 2 fruits here, orange, and let's see what happens. Now it is complaining, right? Because it is not finding a way to actually do this pairing. Oh, so it is having hard time because you are having 2 values here as a list, but city is just 1. Then this particular kind of a dictionary is kind of getting confused in terms of how to properly structure that dictionary into a data frame, right? So that is something strictly defined in the language or in the code. So you can't do this. So I'm just showing you what you can do and what the language restrict you to kind of not do, right? Any questions here? Because these are very starting point, and we want everybody to be on the same page. Let me know if it is all good. Dict and df add. Every name end is required. Name end.
Sir, could you please explain why this error came?
Oh, yeah, because you see here, you are saying that I have 2 fruits, right? And then you have like 1 city, right? And then you have 4 prices, right? Earlier, what it was that you have one, and then you are expanding on like multiple prices and months, right? But now this is kind of a dimension mismatch. Let's say it was like 2 city also, for example. I don't know if this will say Bombay or Mumbai. Still, I guess it will complain because you have this dimension mismatch on this side. But this structure will get complicated, and probably you will not get the proper values that you actually want. Let's say I just repeat this. I'll explain just in a bit. I'm just going through. Now you see, I put it as a list, but it's kind of a meaningless, right? So using a dictionary, you can define a simple kind of a data frame, but it's better to have kind of a defined file that, let's say Avinash has went through that mall customers, with that we will revisit. Taken that file, and I hope everything is this file is with you guys so that we have easy time to be on the same page, right? So here what you're seeing is, yes, it made the data frame, but now it's like okay, it doesn't look like what we want in terms of like the price is kind of not in a right kind of a format or something. It's a list. You can play with it definitely, but then you have to do a lot of mapping and everything, right? So the reason of error coming in is because of the dimension mismatch, right?
Okay, sir.
Fruit price dict fruit. Oh, no. This is just for your convenience, because you always code in a way that you think of yourself that let's say 6 months down the line, somebody else is reading your code, right? So you want to put some kind of a suffix so that it's easy. That let's say you defined it in the beginning, but then you're using it like 100 lines down. Then at least if you have that memory, right, or just encoded in the name, then it's actually easy to play with it, right? Otherwise, every time you have to say, oh, what is the type of this, right? You keep kind of debugging like this, right? If you had put this dict as df, then somebody else will just get confused. What is this? Sorry. If I had that earlier written, right? So that is why we put it's not a requirement. Okay. Yeah. Yeah. But now let's actually go back to the data frames. The name, actually, the whole data frame name is coming from this R concept. Okay. So if we want to actually look at what things actually we can do with the data frame, then we look at this help. I think I went through this earlier. If you want to learn or read more about what a particular module does, you just do this help, and then it will give you everything that it can do, something like this, right? So you're reading the documentation right here in Jupyter. Is everybody able to do this one? Just question mark and pd.data frame and then hit enter. If I can hear a couple of yeses, then it'll be good. Great, great. So let's say if and so because this is a big module, you also have some modules. Let's say if you do dot again, right? Then you are actually getting what you can say is that methods that you actually apply on the on your data, you know. So you can see this append, apply, assign, many things. Maybe some will be there, some is there, you see. So we'll kind of, we can't cover everything given the time, but you should know how to actually use them. So for example, let's say you want to do the sum, but you don't know how to use it, then you just do this. And then actually it will tell you how we do this, how it can actually do the sum, right? But as I said earlier, we want to actually first understand the structure of this data frame so that we can then apply whatever logic that you want to do, right? So just to kind of exercise the data frame and their methods and this learning the skeleton, let's just actually import this data in our Jupyter notebook by reading this particular file. So what we are doing here, this is also important, how we read files. Okay, and I want to spend a minute here. Let's see how in a bare form the file looks. Is there a way? Let me, I think, give me 1 second. So this is how, okay, are you guys able to do this one? Put a exclamation sign and head mall customers.csv. Can I get a couple of more yeses? I want to get yes from a machine that a window machine. Are you able to do this? Somebody using a Windows machine and get this one running. It is exclamation mark head and then mall customers.csv. Okay, I think I can't wait for that long. But anyway, so what this data is a CSV file separated by comma, right? So here you are saying that you already imported pandas, and then you're saying read a CSV file, read underscore CSV. Head is not recognized. Okay, I understand. For the just have a look here. I know it is a Linux basically command, so in Windows probably it will not work. What this one is basically saying is don't run it on Jupyter, run it on the terminal, as you may have had your classes on 18th and 19th on the Linux. Head is basically gives you the top 10 lines of a file, right? So we are just viewing it here by telling Jupyter to run it on shell and then give us the output. Okay. So this is a comma separated file. So what we are saying here is read this file you can see that we have put it in a double quote, right? We are not just saying mall customer.csv. What would happen if we say mall customer.csv? Can I hear some answers? No such yes, no such, yeah, Jinkwan, yes, you are right. An error because now when you don't put it in the literals, in the strings, then it will consider, oh, there is a variable supposed to be a variable, but it does not exist, right? So you have to put it in double quotes. So keep this thing in mind, right? If I let's say I can say my file is equal to mall, this you can definitely do, okay? If then I can say here my file, right? So now this didn't give me any error, okay, because this variable was defined already, and it is a file name that you put it, right? So anyway, now we have read this file, but I wanted to keep two things in mind also. We put the separator as comma. So here I wanted to spend a minute because as a coder, you should actually define this as your religion, okay? You can't expect others to give you a very nice, well formatted data, but whatever you give, that should be very well formatted. Let's say if you decided that tab is my separator, then keep the tab all across whenever you are giving output or giving a file to your peers or whatever, right? If you decide that comma is my basically, let's say, a religion, right? So you always put this comma in your files. So this is really important because other side gets kind of it had to deal with a lot of things to actually just read the file. You don't want to spend on the technical part to actually loosen on your time to do science, right? So be very wise on this. And then we are saying header is equal to infer. When you say infer, meaning that it will consider the very first line of the file as a column name, okay? Oh, can you show or paste the values written in the fruit price? Oh yeah, sure. Sorry, I actually messed with it, so let me make it. Give me 1 second. I'll just do it quickly. Sorry about this. Okay, so we are saying that yes, read the first line as the column name, right? So now if we look at
Excuse me, sir.
Pardon?
Sir, if we won't mention header equal to something, then what they'll take?
Yeah, that's so here if there is no header, then you say header is equal to none, okay? Then it will create it will have its own index. So it will say 0, 1, 2, 3. Okay, we'll practice this. It's a very good question. So when I say this one, then you see what happens. So if you want to see like head I did here, you can just do in the data frame dot head. Okay, see what is happening. You have these column names as 0, 1, 2, 3, 4. And now this particular column name that was supposed to be there has become a row, right? So then you actually have to probably just look at the file, or at least have a sneak peek at the file that, oh, does the header exist? And if so, then I should actually turn this on, right? So you just say here infer, right? Let me paste this one also, so that because I've gone through it, I've explained what all the kind of material is there, the parameters. So I can excuse myself on this sending this to you guys. But yeah, so let's say yeah, now we did this, and then we are. So here is the thing. What you saw with header is equal to none, this 0, 1, 2, 3, right? They always exist. They are latent right now because all, when you are working with codes, right? They know numbers, right? The values that you are seeing, let's say customer ID, genre, right? They are the proxy to actually go back and look at. So basically 0 is pointing to customer ID. Okay, now we will actually go through indexing and slicing. If you recall, we did when we were doing the list and basically list, and we took a very deep dive into indexing, right? So this is the time where we will actually revisit that. So since what was the structure of list? It was like in very kind of a naive sense, it was just an array of things like 1D, right? You're just walking through 0, 1, 2, 3, 4, 5, 6. What is the structure here? Can anyone just write or say? I'll hold for like 15-20 seconds and then I'll move on. Rows and columns, yes. So you can either walk horizontal and you can either walk vertical, right? So now you have to have parameters to actually give you the freedom to walk on both sides, right? So let's say even if you're slicing, so you can either slice from here to here, like say age and income, only if, let's say, only if you want these 2 blocks here. So then you should be able to do that, and Panda should be able to give you that, right? Then what happens is, as you know, that we kind of do the indexing with the column thing, right? So in list, what was the, like if it was my list, then we were doing 1, 2, 3, 4, 5, 6, right? So when it was this one, then we say my list 2 to 5, then we get this 3, 4, 5, right? But now we want one more variable, right? So let's say if we are walking horizontally, but then we need the other one also, the vertical one also, right? So what is the syntax? Or so Panda actually gives you that. So let's say we go back to mall customers here, right? So first section. So since we have this index of walking, the first one is actually to walk through the rows. So they like here. So you are walking vertically. So here, if you say, and I'll tell you how to actually, there is a method called ilock. So ilock means index based location, right? So, and there is also a function called lock. So it's just location. So I'll go through these two, yeah, or 2D array. Yes, study, yes. You can, yeah, you are right. Like if we do here 2D array, then we can do that way too. But let's focus on data frames so that we can cover the methods more. So we'll just go through the indexing part first in terms of the ilock. So ilock is saying that index based location, right? So as you are also aware that Python is 0 indexing based method. So let's say I wanted to get the first 3 rows, right? So what will I put? I'm walking vertically first. So what do I say? First 3 rows. No. First 3 rows. So first 3 rows means what? 0, 1, 2, right? Because it's starting from 0. So what will give me that range? Yes, yesterday. So you just say 0 to 3. So I walked vertically 3, right? And then I put comma. And now I tell how much I want to actually walk basically on the horizontal side, right? So then I say whatever, like if I wanted only the age and annual income. So what is the index? So customer ID is sitting at 0, genre is sitting at No, but if you only want age and income, so what do we do? Okay, somebody said, Shalima said 2 to 3. Let's practice that. 2 to 3, right? He only got age. Why? Because 2 to 3 is just giving you 2, because it's half open, right? Only 2 is included, but 3 is excluded. So you have to put 2 to 4, right? Then you get both the columns. Is that clear, Shalima? Anyway, I'll move forward. So this is index-based location, right? But let's say you are not, let's say you are presenting somewhere, okay? Then you don't want to scavenge through, oh, where it is located. Maybe somebody say, oh, just give me the age data, right? Then you don't want to go through this, oh, where age is located or something like that. So then it can we actually access through the name of the column, right? Imagining that all the names are kind of unique, or if you have some kind of a repetition, when pandas read it, it will make that column, it will append something. Let's say it will say .1 and then .2 or something like that. It will just make it in a way that you can access easily. Okay. So then let's say, so indexing, there are many ways we can actually do the indexing and slicing. So I'm first going to cover through the column, and then I'll also go back to do through the rows, right? So right now we did with index base. Now we do mall customers. Then if you want to actually get the whole column, then you just say age, right? It will give you everything, right? Here I'm not even using log. I'll go to the log, but let's say here we just practice the log, right? Then again, the syntax for log and ilog will be almost the same. For example, here I just say comma should be there, and here you have to give the list of things that you want, and here as rows, and the list of things that you want as column, right? So if I just say here age, because this is the column, right? Sorry. Oh, wait. So, is it this one? Dot log. What is complaining? This one. Shouldn't. 0 to 2. Okay. Oh, sorry. Yeah, I have to, sorry. My bad. So actually, yeah. So you want everything on the rows. So I missed out on that. So you just say colon. So by default, as you know, if you don't say anything, then it starts from the 0 and end at the whole thing, right? And then you say age. I want age, right? Then you actually get this whole thing, right? Is this clear? Because this is really important. We have gone through indexing. We are just exercising those units now in two ways, like one here and other here, right? So let's say if we wanted more age and sex, right? Like gender, right? So we just say gender. So then we get this 2-column data frame, right? You saw the difference between here. You get a series here. You see this, the difference? If I just say age here, I think I will get data frame, right? Okay, so I have to explain this too also. So ilog is integer location. Yes, ilog is integer location. Yes. 0 indexing based. Integer location of the rows and columns. And lock is basically is a proxy, giving you a proxy to actually access based on the names.
Okay.
Okay. Is that clear? Yeah. So so what we just practiced is the lock, right? So here, let's say you have some kind of a condition, and then you want to actually get the get those kind of a get those subset of the data frame, right? Let's say you only want rows 30 to 50, okay, and that that basically 30 to 50 is coming from some function. You guys have gone through function in previous class, right? So I'll just practice very dummy function and tell you how it works, right? So this particular space is what is a list, right? Here we said column means colon means it's just going from beginning to the end, right? But if I were to say 1 to 5, then I 1 to 5, you don't need to put in the list 1 to 5, then it is basically giving me the first 5 whatever, second to the sixth one, right? Index age type dictor are in column, getting this error, none of the index age. Oh, it's a capital A. Could you just correct that, Harshita? A is capital, so you need to be mindful on that one. Yeah, so what I was going back is to this particular thing is a list, kind of put it in an index form, but here you can actually say found this from a function, okay, a function, right? And actually this function is doing something of your purpose, and then you want to get that slice of the data frame, right? So I can say define this function def found this from a function, and I can simply return, because this is a dummy function, so I just say 1 to 5, okay? Or let's say we were discussing about 30 to 50, so 30 to 51, right? So oh no, my bad. I say list range 30 to 51. I'll go through this. Now you see what is happening. You are actually calling a function from here, which whatever is returning, you got those indexes, and then you are actually explaining the age here. Does this make sense? Now you basically have this, this basically is enabling you to call function on both the set of indices, right? You call for the rows, you call for the column also, right? So let's say only age, right? Then you say here, say def only age is equal to what? Return age, right? I want to take a pause, and I want to see if everyone is on the same page and in terms of understanding, because these are very fundamental parts, and we should be kind of thorough on this. Any questions here? Is everybody able to? Oh yeah, Annie, yes, sure. So I hope iLock was clear. Annie, can I hear yes from you? This is just simply index-based kind of slicing the data frame, right? Right? And what we are now saying is that it's not always like you want to put this number here, right? In real life, these numbers will be you will be getting from some kind of analysis you did, and you got those indices. Let's say if we simply do like odd even kind of thing, right? So you will have a odd function, right, which will generate all the odd numbers or retrieve all the odd numbers from a list or somewhere, right? And then you will have similar functions, let's say on the columns, right? But then that's not a hard-coded number. You just put that function in, and then you actually, it's more like a dynamic thing now. Based on the data, you are actually slicing the data frame based on the, like, say, third-party data, some other data, and then you are applying it on your data frame. So that's why here what it is saying is, you in principle just have to get the list. How do you get the list? Doesn't matter, right? Either through a function, from a condition, whatever, but it should be a list, right? As I'm kind of returning also from here as a list. And let's say in terms of display, I would say there is two, sorry for going back on this, but let me just add above. What I was actually showing as small customers dot look, and let's say 1 to 5, and then we were doing this one, and I actually wanted you guys to have this difference recognized. When I didn't put this as a list, what you're getting is a series. I'll go through that. But if you do and then say mall customers dot log 1 to 5, and then I say age. See the difference here? I'm putting this in the list, right? So now you see the display, it is different, right? The reason it is different is that when you put it as a list here, it returns a data frame, okay? But when you say, oh, I only have a single entity, right? Although this is a single entity, but it is in a list, right? So it is just returning a data frame. But when you just say, oh, I only want the age in this form, then it just returns you a series, because it's just a list of numbers. You don't want to maintain the data frame, okay? This is also again in sync with our data frame kind of a philosophy. So if you know R, then you will be kind of relating to this, what is happening here, right? So any are things clear or better now? Perfect, perfect. Yeah. So so this is really important. Okay. So we covered iloc, lock, right? And we also covered. Let me just repeat that guy one more time. This mall customers dot. We didn't use anything, right? Not iloc, not lock. We just said age here, right? And we got this series. But what if you put this again in a list, right? So this is another way of convenient slicing, right? So if I say customer ID, right? So we get both of them. And also remember, this is or basically observe that the columns are retrieved in a way you give that list, right? So you see in the original form, customer ID was the first column, right? But now you actually want them to be in this order. So then they are actually just put that in order, and then it can basically reorder and give you that. So this is pretty convenient, right? Let's say if you want to put something just for convenience, you want to look those data together, you just reorder based on what you want. Okay. So we worked on, let's say, we worked on columns a lot right now, right? But let's say in terms of convenience, you see, you are now accessing everything through name, right? But again, in principle, it is being mapped to the column ID with the 0, 1, 2, 3 only, right? So then you are actually getting those, right? How about the rows, right? Often you have data structure or like your files, or you try to, okay, I give you this kind of through my experience over my postdoctoral and PhD, that whenever you create file, okay, always have one column that is ID, and very simple could be that you just put line number, either in the beginning or at the end. That actually gives you so much power because that's just unique, right? And what happens through when you're doing analysis, let's say in bioinformatics, you start with one file and it gets sliced, and maybe you started with 10,000 lines of in a file, and then you are only having like 1,000 or 500 lines. And then it will always come up in your practice that you have to map it back, right? Because some extra information was there in the original file, right, which you didn't carry. Then the mapping becomes a problem, like, oh, which 500 were there, you know? So once you have that line mapping, then you can easily just kind of go back by mapping to that, right? So have the primary key always in your files. It's not a database concept, okay, that, oh, I need a primary key or something like that. It's always in your files, just keep it, okay? One column doesn't hurt in terms of file size or anything, okay? So always have that. So now the reason I was going there is because you have this customer ID. You see this? This is unique, right? So in terms of convenience, right, I can put this customer ID as index also, right? Like the rows, right? So how do we do that? So since we are going a lot in the skeleton of data frame, just tell you that mol customers dot index is basically the rows, okay? So index, it gives you the basically this is an object of that Python maintains or pandas maintains in some efficient way. We don't need to go into that details because our goal is to actually understand and do more data analysis. Internally, they have very kind of a sophisticated way to maintain this, right? But if you want to kind of just have a sneak peek into this, we can say that list of this, what you're seeing is 0, 1 to basically 190, 199. It will go like this, 199, right? So numerically it is assigned, right? Right? This thing we didn't have in our mol customer, right? The Python is actually maintaining this, right? But now let's say you have some kind of a convenient kind of a name, right? That you actually want to have that as a row ID, right? Or index. So what we can do is we can assign this index as, how do we access the customer ID? Can anybody tell me? If I was not to use any lock or ilog, what will I do here? I'll just say customer ID, right? And I just want to highlight that you don't need to type the whole thing when you write them all customers and these two kind of this operator. The Jupyter Notebook automatically have kind of access to all these names, and it will try to complete it. So when you write CUS and hit tab, it will complete it. Index plus 1. Oh, okay. That is a very nice suggestion, Teddy. But sometimes you're not sure that when that customer ID has changed, you know. So you always want to be careful that you want to really map the customer ID. You don't assume that, oh, it's always a +1 relation. Okay. What Teddy observed is that, oh, since here it is starting from 0 and then customer ID is for 1, so naturally there is a +1 relation. But please avoid doing that. Even though it is +1 relation, you just do go with this this kind of a assumption, this kind of a way. So now what happened is, let me know, I want to hear a couple of yeses on this one. Is everybody able to do this? Great. Okay, nice. So now let's see what is happening. So I want to kind of alert you guys also on this a little bit. Now you see mol customers dot head You see now the things have changed a little bit. What earlier used to be and 0, 1, 2, 3, something like that, but now it is just 1, 2, 3, 4, right? So now you have to be careful because earlier here it was like zero based indexing. So when I let's say if I read one more time again here and I say mall customer dot ilog 0 to 2 and sorry, and then I say this, then I'm getting this, right? But now here here the philosophy has changed here a little bit because customer ID is the, or let me just get one thing. Okay, so yeah, just 2, right? So 2 is getting what? Your 3 this particular row, right? Kind of a showed in this way. But now if I do this guy, once I do the customer ID and say my customer mall customer dot log and say 2, now I'm getting 2. You see this difference? This is really important. So you see the difference between log and ilog. Ilog still will access through the index. I think if I do ilog here, then I'll get 3 as you were getting the 3 here, right? With the 2. You see the difference? But when you're doing with log, it will access the name that you are given, okay, that you have actually given, right? So see the difference? It is now giving 2 because now it is looking at the customer ID. And that's where Teddy is the difference of this +1 is happening right now, okay? So the reason I wanted to elaborate on this one is because you will have sometimes hard time, oh, where this, I messed up the indexing. Although we just covered today, let me walk a little bit more on some more things that you can actually do with the pandas. This thing is important. This thing will be used a lot. What all else I had? Oh yeah, yeah. Okay. So yeah, so 2 things. If we look at mall customers right now in this given form, here, right? This is called in kind of a language of tables. This is a wide format label. Okay, this is a wide wide table. Okay. The reason it is called wide table because you have many columns. You can have more columns added like this, right? But there is also there is also a table called long form. So wide and long. So what is the concept of wide and long table is, if you are familiar with R, there is something called melt. So what you are basically doing is you pick one variable, let's say age, right? And then you actually flatten this whole table as kind of a long number of rows. So let's say you have this 200 rows here, right? And if you're flattening it with the age, right, then what is happening that you have other 1, 2, 3, 4 kind of rest of the columns, right? All will be flattened by the values of the age. So let's say you have this first row, right? NaN, right? But what are the associated values of other columns with that particular age is again, it is NaN. We try to kind of avoid it, but anyway, just for the sake of this example, let's say, take the column 2. You have this age rows 2. You have this age 21, right? And then we have customer ID associated as 2, male, and 15, something like this, right? So what we do is we say 21, 21, 21, 21 4 times, and then these kind of column names are now also as given in the rows. Let me just explain how it works. So you're melting it. Basically, you had this wide kind of ocean, and then it's just passing through a river, defined by the age. Okay, so this is how we do it. Okay, mall customers dot melt id vars is equal to age, and this has many applications that we will go through. Here, I think I'll do some more plotting in our next class, and go through the NumPy, because data analysis is also important just through the viewing. But this will come in handy when we do that. So here we say mall customer dot melt, right? So what is happening now is what it is doing is it is taking this this customer ID first. It start because you're melting on A, so it is walking through first customer ID, genre, income, and then spending score, right? So you are seeing all the entries of customer ID first, right? So 200 of these customer IDs are now actually flattened. You see that what is happening here is you flattened it, you kind of melted it by age. So age is that column by which you melted it. What is the variable now is these columns. Okay, so it started with customer ID. So you put 200 of these first here, and then you put the genre, right? And then you put this annual income, and then you put this spending score. So at the bottom, you're seeing this spending score. So what is the advantage here now is that these variables are now put it as a column, right? So let's say you wanted all the customer ID from here, right? So you say if it was, oh, please repeat. Okay, sure. So you see the difference between these two tables. You see it is thinner when you melt it, and this is wider, right? However wide you make this, it is possible to have 100 columns, right? But then if you melt it by age, then you will have this very long, only with the 3 columns, right? By which you melt it, by what like whatever rest of the variables are, and what are their values. Is that clear, Lakshmi? Maybe I put the okay. Thank you. So we will basically use this a lot. I think it is also used very widely in R, where you first flatten it and do the plotting as you want it. Okay. Because the reason it gives you that advantage is actually you can define the categories on the variable, right? So so then you can actually, as a function of age, you can see how these categories are actually changing. This is a dummy data set, but we'll try to get some practical. I'll share one more file maybe today, so that we can practice tomorrow. I'll email Praveen and he will share with you guys on which we can actually do some kind of exploratory data analysis. Okay, so that will be very handy in terms of if you have your own data, how we actually work on it. For example, here as I was saying in the beginning, there is no shame in Googling and kind of because this language is evolving. I think at the time when I was basically going through exploring this Python language, this thing was not there. Like what I'm trying to show here is, let's say you do this data frame. Let's import by as np, right? And so how this data frame right now is looking is like 4 columns, right? You just have some random numbers here, right? And then you can actually do box plot right from this this data frame structure itself. And this was something that I think it was not there in the beginning, right? So what you do is box plot is equal to df dot box plot. So it is just giving you this graphical representation. You can do it with your real data, right? Just calling this box plot, right? With these columns. So again, it is nicely ordering also in what way you want. Let's say if I do column 2, I think it will put the column 2 in the beginning. See, call 2. So these are the way actually you can kind of visualize very nicely, you see. So that's the power of pandas. How do we save this plot? There should be, if it was a Seaborn, then I would know that plt.save, I guess. Let me see. I'll tell you later, because this is something that new I just learned. I was not aware of this kind of power of pandas earlier, but I'll do let you know. Let's say if there is a, so if you're naive on this, then let's see what is there. Do we have like save? No, there is no save. I'll let you know later. Maybe we need to import NumPy and something else, random library, to make that work. Oh yeah. Here, import. Sorry. Let me paste this guy here. Sorry. I should put that in. But yeah, we will cover more on. What I'm thinking is we do pandas a little bit more, maybe 1/3 of the class tomorrow, and I also then tell you the NumPy. Because that is something also important in terms of scientific analysis that you do, and that way we can kind of conclude the pandas and NumPy. But we have basically covered the fundamentals, which is really important, because and we'll do the application part tomorrow a little bit more in terms of plotting and doing those kind of analysis. The exploratory data analysis is something you always do before applying. You want to know what is the behavior of data, how it looks like, what kind of distribution we need to fit, something like that, right? So you always want to plot your data in the distribution, the box plot, line plot, something like that. Like if you take two variables, you want to see how they are behaving, right? So we'll practice those things in tomorrow's class. I want to get that thorough. Maybe we compromise a little bit on NumPy, but it's okay. Doing this kind of a graphical analysis also give you some kind of a nice motivation to be on Jupyter Notebook and do all this kind of things, right? I think that will be all for today. I'll send a file to Praveen, and he can share with you guys today, so that we can do those kind of analysis tomorrow using pandas itself. And then
can you show the box plot coding, because I am typing, so that's.
Oh yeah. Of course. Sorry. Here.
Yeah, just down one. Just okay.
Box yeah.
This one, okay, sir. I'm trying. Yes, that's okay, sir. Okay, sir.
Yeah. So I want, that's why, sorry, I'm confessing here, because I just learned it. I just googled doing box plot from pandas, and when I was learning this pandas, then this thing was, I guess, not there. It's just I think it's very new, this particular function, or maybe I've not explored at the time when I was learning. So that is what I'm saying, that you should try to hit the right keyword and you will find answers. The crux is that you should know how you are kind of playing with your data frame, like slicing, indexing. This thing, you may not realize the potential right now, but this is very, very, very powerful. Okay, very powerful. Because the reason is you can do some complex things here to get the indexes that you want, but the idea is to make that very nicely readable. Okay, the thing is you can pass variables, and like it's a proper function, right? So this is giving you the freedom to actually apply your logic in here. You can make this very complicated, just writing everything in here to give a list, but then you can actually abstract it with a function. So it is very powerful. All right, Praveen, I guess we
Okay.
can conclude here today.
Okay, sir. So thanks, Dr. Rao.
Yeah, let me, sorry, Sandeep, Praveen, give me a second.
Okay, sir. Okay.
Sandeep is saying that copying this, pasting this here. Yeah, sure. Is that what you needed, Dr. Sandeep, or more? This guy also? I think I put this one already.
Yeah.
Okay, cool. How we can change directory? Oh, are you on Linux or are you on Windows, Mehtab? I think it will work on both. If you are there, let's say, I mean, if we do this not cd dot dot, I think this will work. And I guess if I do not ls, I think it didn't work. I need to look how to actually go from in Jupyter Notebook to different directories. I imagine. Okay, no, not cd dot dot. Yeah. Now you're there. If you do pwd, yeah, not cd dot dot. Just do cd dot dot. Yeah. Oh, I want to change from C to D. So I think you just say C and CDD or something like that. I'm sorry. I this is a Linux like Mac system, so I cannot be on sync. But something
नहीं है, वो लोग वहाँ का है। टीसी तो नहीं सर अभी दिया ना, अभी तो एडमिशन नहीं हो तो बातचीत करना, बताइए।
Could you please turn off your mic? I don't know who is speaking. Rakesh. Yeah.
So I muted the sir. I muted.
Yeah. Okay.
Now I think
it's
time to end today's session. And again, I would like to express my sincere thanks to Dr. Rao. Without your sessions, this workshop will not be as productive as.
Thank you.
So
you know, like I'm glad people are learning something. The I feel like going through fundamentals is important, because later on you can actually put your own logic. Fine. Learning the language is just going through the pieces first, and then of course you can do your own things.
So bioinformatics is increasing as a career option day by day in India. And and people like you and Dr. Mishra are central to programs like ours, which provide affordable bioinformatics education to all. So
I'm happy to be a part of it.
So all the participants are saying thanks. And tomorrow Dr. Rao will be with us again.
I want to focus more on visualization. I think that will give you more kind of an aesthetic feel. And then you can be more drawn towards how to actually look into your data. Sometimes data is like overwhelming. Oh, what to do? So then you can do actually.
And please kindly note that the last session of this Python module, that is on 1st of May, is scheduled for later, after machine learning module. So kindly note the change. There will be no session on 1st, and Dr. Rao and Dr. Mishra have set the stage for a machine learning model, which is also going to be exciting. Dr. Salman Sadullah Usmani will deliver on machine learning aspects of Python in bioinformatics. So thanks, Dr. Rao, and we will share the Python file of this session with you as soon as possible, and we will also share the Jupyter file of yesterday's session.
I may take some time in giving you the file, maybe like, let's say tomorrow morning or something like that.
Okay, so no issues. I will share the video recording now within 2 or 3 hours, but I will share the Python file tomorrow.
Yeah, sure.
So
No,
thanks.
I was saying about the additional file on which people will do the.
Okay, sir. Okay,
plotting
okay,
and other
okay.
things.
Sir, you share me. I
Yeah.
will share it as you
Yeah.
share it with me. So with these words, now I seek your permission for ending today's session, sir.
Yeah. Please do. Thank you.
Thank you, sir.